especially with the parabolas. Again, these are all from section 5.1. So if you're having issues, that's where you want to be. When we're doing standard form to find our vertex, it's the one that takes the longest. To find my x value, I'm going to use negative b over 2a. Okay, I can't change that up at all. So when I figure that out, and we will here momentarily, that number is going to go right flat in the middle of my chart. Now, some of you are saying, I just want to type it on the calculator. You can, but again, remember, you still need to know where the vertex is. So negative b would be negative 2 in this case, over 2 times a. My a value is negative 1. So negative 2 over negative 2 is positive 1. That's going to be my x value for my vertex. Okay, that's going to go in the middle of my chart. Like we said before, once I have that x value in the middle, I want 2 values that are less than that, and I'd like 2 values that are greater. Now again, at this point, you can type this into the calculator to get to where your x value is 1. Okay, so you could just say like, all right, I am going to get my handy-dandy calculator working here. And I'm going to go ahead and I'm going to plug in. And again, you can do it without it too. It's not like it's an absolute necessity or it's not possible. So once I have this and I go ahead and I graph it, I know it's supposed to open down because it's negative, so that's a good thing to see. If I do second graph, when I get my x equals 1 to the middle of my screen, it should be symmetrical if I've done this right, and it is. So I got 4s right around it, and then 1s, and then negative 4s. If it's not symmetrical, you have done something wrong with your vertex. Yes. So here, so I've got 1, 5, and then my 0 and my 2 are both 4, and my 3 and my negative 1 are both 1. So the only thing I really had to calculate here was the x value of the vertex. Because once I knew where that midpoint was, I knew once I put it on the calculator and got that x value from the middle, I would see the symmetry that I was looking for. So then I can just go ahead and plot my point. And draw my parabola in. Again, parabolas should be U-shaped and they should be symmetrical. So I'm just saying, that's what I should be doing. Again, that's the longest one. With the calculator, it's not really that long. Otherwise, I'd have to plug in some values, and I just plug values into the y equals for x, and I can find the y values that way. Kind of old school way of doing it, but it works. For the rest of these, the same idea is going on, except now the vertex gets a little easier to work with. What's my vertex going to be in number 2?
Negative 1,
1, negative 3. I did not tell you you were wrong. So 1, negative 3. The opposite of what I see in the parentheses, and then I use this here. Now, that still doesn't mean that I don't need to chart this out. But again, I have my middle, and I want the 2 values greater than and less than. So once again, if I choose, I can go back to the calculator. I'm going to scoot it over so we can actually see it. Make sure you type it in exactly like you see it if you're going to the calculator, because sometimes operator error can cause us issues too. Or you can just go ahead and plug the numbers in. I mean, it's not like they're big and huge and nasty by any means. So I see it stretches a little. And when I go to my second graph, my 1's in the middle, and again, I see symmetry. I see the same values working their way out. So I can go ahead and say, okay. And I also noticed 1, negative 3. Okay, so it kind of reinforces that I did this right. So once I get that filled in, I can get my parabola drawn in. Vertex is easier to find. Once we have the vertex, life is easy. The vertex is the thing that can cause us the most issue with it. And then we get to the easy one. Intercept form. What are my two intercepts going to be on this one? How would I find them? If this was factoring and I replaced this with 0, what would you tell me to do? Right. I'm setting these each equal to 0. So if I set these each equal to 0, I get x is -6 and x is 2. So I'm going to plot those 2 points. Okay? And this is the one where I only have to have 3. I only have to find the vertex now. So I can either start counting in from the edges until I find that central point, which in this case ends up being at -2. Oops, I haven't been putting my vertex in. Badly. But then again, to find the y value, I just plug it in here. So -2 plus 6 is 4. -2 minus 2 is -4. So -4 times +4 is a -16. You're like, Harty, that's way off the screen. We'll just kind of half eyeball it. Sometimes they may go a little off our graph. But with the intercepts, again, find the intercepts, you find the vertex last. This is the only time that actually is going to happen that way. So then I notice down at the bottom, it talks about an axis of symmetry. How do I find that again? That shouldn't be real tough here. Okay, so what do I... Okay. So yeah, it's just x equals and whatever your x value is in the vertex. And again, that's the line where if you were to fold your parabola in half, you would end up getting symmetry through there. So that's kind of our review of section 5.1 with our graphing of parabolas. Then here comes the factoring again. Scooch up a bit here. Factoring, we're back into 5.2, and again, notice these are all the equal 0 types. Here we're just looking at a diamond. What multiplies to -20 and adds to 8? Okay. 10 and -2. But again, the equal 0 means we're actually trying to solve. Okay? X equals -10, x equals 2. Got to finish it off, got to solve it. Okay? But notice it says solve by factoring. So make sure you're showing me the factored form before you get there, or on you. 5. Always be curious. Yep. It does factor completely. It says that. Okay. So, nice. Okay. One option you have, if you notice it, because some of you are going to say, okay, can I take something out of all these? No. And you're going to go into slide and divide mode, which is fine. But if you notice, your first and last terms are both perfect squares. That's going to speed this up, possibly. If you notice that, you can sit there and go, okay. Now, we're going to go a little slow. Ben's got a real quick idea, but I'm going to go one step a little slower. I'd say, okay, what do I square to get 16? Well, that's 4. What do I square to get 9? Well, that's 3. And then I just steal the sign from the middle. Like I said, slide and divide would work. So if you're more comfortable that way, you can do that. But then setting these equal to 0, I only have to do one of them, so they're the same thing. I can add my 3 over, divide by 4. 3/4. But again, slide and divide would work. I'm not going to sit here and say, no, you didn't do it the shortcut way, wrong. That's not how I do it. All right. And then right. Whenever you're doing these, the other big things, I mentioned it even on 15, even though there wasn't one, if you have a greatest common factor that you can take out, you may even have a variable term with it sometimes. All I'm factoring at this point is what's inside the parentheses. The 3 does not exist to me right now. So I'm just looking, luckily, now that it's just x squared, for two numbers that multiply to -8 and add to -2, and I get those. And again, if the 3 would have had an x that I could factor out, then I'd have had to set that equal to 0. But since there's no x with this, I don't do anything with it. All I'm going to do is set what's inside the parentheses, each quantity equal to 0. And I'm set. Okay? And then 7 kind of goes along with the theme of 5. Perfect squares again. What do I square to get each one? Yep. 5 to get 25. 7 to get 49. And since it's -49, I get one of each. Again, knowing your perfect squares kind of comes in handy. Set that equal to 0. And work on getting my 2 solutions. 7/5, 7/5. And basically, those are the only 4 options you're going to run into. I mean, we didn't do a classic slide and divide, even though you could have on 5. But a difference of squares, finding the greatest common factor, just doing, the regular diamond type thing, that's going to be things that are going to show up on here. And are going to keep showing up. Because factoring is a big part of what we do. So, as we head to now we get into what we were talking about yesterday. Okay? Solve by using square roots. You've got to isolate your x squared. Okay? So add the 8 first. Good call. Divided by 2. And now comes fun. Whenever you have squared, remember there's going to be 2 answers. You only get one, and it's only half right. So when I do the square root, it's going to be tempting to just write plus minus square root of 28 and go on to the next one, but we're smarter than that. Yeah, we can break this down. If there's a perfect square that's a factor of 28, like 4, we need to break that down. So this becomes plus minus the 4, perfect, it's out of radical jail with its new identity. 7 continues to act irrationally. It has to stay in. Will that be the case every time? No. Sometimes you may not be able to break it down. But for this one, that's one we've got to be able to do. 9, I found out I'm one section ahead on this. So the true answer we're not going to be able to get to, but we'll talk about that in a minute. What do I have to do first in number 9? Subtract the 6. Then what? Multiply by 5. You get -10. Now when we hit next section, we'll actually be able to simplify this. But for now, we can't. So for now, we just have to be content with plus or minus square root of -10. Because next section, you'll be introduced to the wonderful number I. And we'll actually be able to break these down more. Not quite yet. One section away. I got a little ahead of myself here with this question. So that's as far as we can go right now. Last one with the roots. Square root right away, because here's the difference. Notice I don't see parentheses in 8. I don't see parentheses in 9 getting to my x squared. 10 I have parentheses, so I've got to deal with those. So again, squared and square root are inverses. Ooh, square root of 16 breaks down nicely, plus and minus 4. We mentioned this yesterday. Simplify completely. I don't want to just see this as your final answer. We know what 3 plus 4 and 3 minus 4 are, so I actually want to see the two solutions. 3 plus 4 is 7. 3 minus 4 is negative 1. Radicals, I can leave alone. That's fine. But once there are no more radicals to play with, I've got to simplify things. So that, again, that kind of gives us another review of what we were doing yesterday in the 5-3 stuff. Move down a little. The area of the rectangle shown is 42 square meters. Find the value of x in the dimensions of the rectangle. How do I find the area of a rectangle? Length times width. So, or width times length, either way, equals the area. So we actually have to come up with the problem this time. Once I get here, of course, we'll distribute through. But whenever I'm looking to have to factor something, I always need to make sure all the terms are on my x squared side. So the 42 is going to need to come over, and I have to subtract it over to do that. So instead of them just giving me the expression, I had to come up with it, but that's all right. Do all three of those terms have anything in common? Unfortunately, no. So what's our option? Slide and divide. We need to factor. What? Where? Why? Oh, Harty's going to pause for a minute. Okay. Explain. Details. True. That is true. That's a good point. It could, since I know it's going to be 3 and 1. Now, 42 could give me several options, but for some of you that can go into the guessing check with that, that's definitely an option that you could use and might like on this one, because some of you are going to look at this and go, ooh, 126. Ooh. 14 and 9. Okay. Negative 14 and positive 9, because I knew with the negative here I was going to have one of each sign. So basically I was going to have to find two numbers that had a difference of 5. But again, remember, this is not called slide. It's called slide and divide if you go this route. 14 over 3 doesn't reduce. 9 over 3 does, though. So when I set these equal to 0, because again, when we're doing the factoring, that's the route we got to go. What did I just do? Oh! You did. No, you did. We even have video to prove it. Yeah, you did. All right. Fix that. Thank you. So we're going to end up with negative 14 thirds and positive 3. But we know a dimension can't be negative. It's kind of silly. So that gets rid of the 14 thirds. So my x value is 3. And again, to get the dimensions, I just plug it in. My width is 3. My length is 3 times 3, 9, plus 5, 14. I've got it. Nice to put my labels on. Okay, so we get a little of everything there. We get our formula. We get getting all of our terms to the x squared side. We get the factor. We get the plus. That's kind of a nice complete problem. So then, so when we bump up a little, Hey, an egg is dropped from a height of 105 feet. How long does it take for the egg to drop to the ground? Remember, h sub 0 is my initial height. This h it would be my final height. So when it hits the ground, how high is that? 0. And my initial height's at 105 feet. So again, whether you choose to subtract the 105 or to add the 16t squared, you're going to get the same answer at the end. So if I bring this over just to keep things positive, and then divide by 16, yeah, even if you went slightly rounded, but I'll just go ahead and put it up here. And then square root that. Yep. The egg is going to hit the ground in about 2.56 seconds. So if you're on the bottom of that, you might want to move quick. 2.56. An egg. 105 feet, 2.5 seconds. Boom. And then finally, they're like, oh crap, Harty. This isn't in 5.1 or 5.2. I know. But we've got to make sure that we get this. So here, again, you'll want a pencil handy. Negative 2x plus 6. Plot your intercept. Down to and over 1. Down to and over 1. Down to and over 1. You're like, Harty, when are you going to stop? Down to and over 1. Right here. Because my line starts here. And I'm going to write this in like this big of letters. If some of you are not doing this tomorrow on that quiz, your line has got to start somewhere on x equals 4. Here, x is less than or equal to 4 means I want the part to the left of it, which is nice because that's the dots I have. Is this dot going to be open or closed? Closed. Okay? Closed dot going to the left. Okay? That's the only part I want. I don't want this part. I only want the part that's less than going to the left. The other one, what's my y-intercept if I don't see one? 0. My 0. Down 3. Right 4. Down 3. And right 4. So I go, oh, I already got my dot. Here's 4. X is greater than 4. Which side of the line do I want? To the right. So here on this one, what's my dot going to be, open or closed? Open, because it's just greater than. And going to the right. But both of my lines start at whatever number this is. They cannot start anywhere else. So basically, you are staring at the quiz. You have this in front of you.